Assalamu alaikum warahmatullahi wabarakatuh. Today we will take kinetic model of matter for grade 9. What is the matter and the states of matter, and how can it change from state to another state? At first, matter, anything has mass and occupies space. Okay? States of matter, 3 states: solid state, liquid state, and gas state. Changes of states, how can we change from state to another state? Solid to liquid by melting process. From liquid to gas by evaporating process. From gas to liquid by condensation process. From liquid to solid by freezing process. Kinetic model of matter. What is the meaning of kinetic model of matter? It is a model in which matter consists of molecules in motion. All the matter is composed of molecules, as you see, in liquid and in solid, liquid and gas. What about the kinetic theory for solid, liquid and gas? For solid, its particles are not free because they are close to each other and are held in a fixed location, so they vibrate in their position. In liquid, their particles move relative to one another, and in gases, its particles move rapidly and no attractive or repulsive force because they are far apart for each other, okay? Its volume is very small, and its kinetic energy here increases by increasing the temperature. The kinetic theory of matter. The kinetic theory is a way to describe what? To describe the motion of the particles. It states that particles in all the forms of matter, solid, liquid, and gas, solid, liquid, and gas, are constant motion. In solid, they are vibrating, in liquid sliding, and in gases flying around. When the particles is moved in the matter, okay, so it produces an energy which is called kinetic energy. At higher temperature, the motion increases and they collide to each other. When the particles collide to each other, the hotter or the faster particles will transfer heat to the colder or the slower particles. What is the difference between solids, liquids, and gas in forces and the kinetic energy? In the energy in the particles in solid is least energy. In liquid is energy, and in gas is most energy, and the forces between its particles for the solids are strong forces, in liquids is strong forces, and in gases no forces, attractive or repulsive force. Boyle's law. This is a law in the gases law, okay? Boyle's law, it is the law that relates the pressure with volume at a fixed mass of gas, okay? When the temperature is constant here, PV will be equal to constant. PV equal constant is the Boyle's law, where P is inversely proportional with V. If we increase here the pressure, the volume will decrease. And if we decrease the pressure, the volume will increase. We can write the same idea, PV equal constant, by another way, P1 V1 equal P2 V2. This is when we have two states for the gas, initial state and the final state. This is the initial pressure and this is the initial volume, and that is the final pressure and final volume. PV, P1, V1 for the initial equal P2, V2 for the final for the gas. P1, V1 equals P2, V2. This is Boyle's law at constant temperature, okay? This is two graphs represents the result of Boyle's law experiment. This is the relation between pressure and volume, okay, against volume, and that is the relation between P and the inverse of the volume. Let's answer this problem. If we have a cylinder contain 50 centimeter cubic of air at a pressure of 120 kilopascal, what will its volume be if the pressure on it is increased to 400 kilopascal? He gives you here the initial volume 50 and the initial pressure 120 and the final pressure 400, and he wants from you to calculate the final volume. Substitute in the Boyle's law, P1, V1 equal P2, V2. So V2 equal 120 multiplied by 50 divided 400, it will be 15 centimeter cubic. This is the final volume. The initial volume is 50. So the volume of the air is reduced from 50 to 15 centimeter cubic when it is compressed. Your homework, answer the questions in the course book, page 122, 125, and 126, and 128 from 9.7 to 9.20. Thanks.